Okay, the next example, we're still in 4-1, yep. Just so the recording shows it. Okay, is the integral of x cubed plus 3 over x squared dx. Okay, so again, we don't have a quotient rule that we can use right now, right? We don't have anything else. So we need to bring it out of the denominator. So it would be what? X to the negative 2 times x cubed plus 3 dx. And so then I just distribute it. So what would I get? X dx plus
3x negative
2. How about 3 the integral? Why would it be 3 the integral? Yeah, bringing our 3 out. Again, we don't have to bring that 3 out. It just allows us not to think about it for a minute, okay? It also will help us when we have to figure out what happened to some things. Okay, so what is the integral of x dx?
2.
You get 2 and then divide by 2, so
1/2.
1/2 x squared plus
Plus 1/3.
we would add 1, so it'd be negative 1, and then divide by negative 1, so it'd be not positive, but negative 3 x to the negative 1 plus c, and we obviously cannot leave the negative there, ever, right? So 1/2 x squared minus 3 over x plus c. Or can I write it 3 times 1 over x plus c, if I like that better? Yep. Okay, while I help her, I'm going to see what you guys can do with this. The integral of the cube root of x times x minus 4 dx. What did you guys do?
Well, I only rewrote it.
X
That's all I
to the
added.
1/3.
Okay, and then you distributed?
Yeah.
Okay, so we have x to the 1/3, and then you distributed. So you have the integral, and 1 and 3 would be 4/3.
Yeah.
Okay, dx minus 4 the integral of x to the 1/3
Yeah, now I'm lost.
dx. Why are we lost? What's our integration rule?
1.
Add 1 and divide, yes? So adding 1 would be 3 over 3, so you would get what? 7/3. So write 7/3. Now multiply by the reciprocal.
3/7.
3/7. Once I write 7/3 down, can I see it? Yes. Okay, so this one we're going to take another step, so we don't want to jump too far. Okay, so add 1 to 1/3, which would be
4/3.
4/3, and the reciprocal would be 3/4. And then plus c. So what's 4 times 3/4?
3.
3. Do you see how writing that exponent down can help me out? So write it down. So what about that got you scared?
The first thing.
The first thing?
The rewriting.
I don't want to add wrongly to my fraction.
But you are getting better at your fraction addition. I am so proud of you.
Kind of.
The cube root. Cubicle? No, cubicle is something you work in. Okay, so what we have been finding are general solutions. Now let's find particular solutions. What do you think a particular solution is?
I don't want to know.
Or something dumb.
No. Okay, general solution is what we have the plus C, yes. Particular solution, we find the C. So we do everything else, and then we plug in an initial condition.
Can I get this down first?
You'll get it down. Okay, so find the particular solution for y equals the integral of 3x squared minus 1 dx using the initial condition of f2 equals 4. So we got an x and a y, yes? Yes?
Yeah.
Okay, so we first have to do our integral. So add 1, divide. So adding 1 would give you what?
Well, wait, they got the 3.
Well, okay, I just skipped.
Miss Vic, you got it.
I know. So we're doing this.
I'm still writing down the example.
I am too.
Wait, isn't it x squared?
Oh, yes. Forgot my squared. Okay, so I separated up, right? So add 1 and divide. So adding 1 gives me 3. Well, 3 divided by 3 is 1, so that was good. And then minus
X. Nothing.
x,
Zero?
x, because there's a 1 there. Yes?
Oh, yeah.
And then plus c,
Let's see.
and that equals y. This is the difference of what we were doing before, okay? We were doing before, this wasn't equal to anything, was it? Now it is equal to what? Y. So what did we get over here? This is an x and a y. And I think I have an x and a y and a c. So if I plug in my x and my y, can I find my c? So here is my general solution. So I need to find my particular. So y is 4 equals 2 cubed 8 minus 2 plus c. So 8 minus 2 is 6 minus 6. So c is -2.
Oh.
So now what do you think I do? Plug it in for
See?
C. So the particular solution is y equals x cubed minus x minus 2. So if I were to graph this, it would look something like this. And if I would change this initial condition, my graph would have the same shape. It would just have a different x-intercept, correct?
Yes.
And so it would move up and down that. I said x-intercept, I should have said y, because that's what the constant is, right? So it would move up and down that y-axis. Same shape, just up and down that y-axis. And our perception would maybe make it a little bit different, but it's still going to have that same shape. Make sense? Okay. So you're still doing what you were doing. You're just plugging in at the end. So f prime equals 1 over x squared. And it says x has to be greater than 0. Why? I don't know why. Why? I don't know why. They just want it greater than 0, evidently. Because there's not a restriction on x squared, is there? No. Okay, so this is the same as y, isn't it? Okay, so y equals, well, it's not the same as y, but it will be once I take the integral of it. Equals the integral. And how are we going to rewrite x?
X minus 2.
How about x to the -2? But yes, I knew what you meant. Dx. So the last one was already written in integral notation. This one we just had to put it there. So add 1. What do you get?
-1.
-1 and divide by it. So it is negative.
Yeah.
So negative x to the -1 plus c. So that's just y equals -1 over x plus c. So now I plug in x and y. So 0 equals -1 plus c. So c is 1. So again, general solution. So the particular solution would be y equals -1 over x plus 1. Actually, the better general solution would probably be this one, wouldn't it? With the -1 over x. So, hard?
No.
No. You're doing what you've been doing.
Done.
Yep. Hopefully